Hey everybody, my name is Alex with Hake Hardware, and in today's video I'm going to do an updated video for farming clusters. I just moved into a new house, which is why it's a little crazy back there. I also don't have all of my servers anymore. I don't have enough space and I don't have enough power run to this office, so I just have a single server and then a second server that I'm using for farming cluster. So my new setup is a little bit different, but because there have been a lot of changes from subspace to autonomous as far as the naming conventions go, my guide is pretty outdated. It doesn't work very well. So I'm working on an August 2024. This is technically it's July 31st when I'm doing this, but it should be pretty valid for most of August. Um, but I want to cover a few things, and I already have my setup going, so this is going to be like a typical tutorial where I go through step by step and show you. But the document here, this article has all the steps, step by step, basically. So with clusters, I recommend doing them whether you have one server or two or three or four. I think it works well even if you just have a single server. So a single server cluster looks something like this, where you have your server, and then on that server, you have your node, you're running nats, and nats is kind of like what all of the cluster components talk to make everything work. So you have a controller, a cache, a plotter, and a farmer. And if you're not running clusters, you typically just have a farmer, and these three things are sort of inside the farmer. So I like the compartmentalization of having each of these as a dedicated container. And so this would be what it would look like if you just have a single server. I run it similar to this, where I have two servers, and I run my node, because the node isn't really part of the cluster. The node is its own thing. It doesn't talk to NATs. It talks to the controller, and that's it. There's a connection between the node and the controller, and then all of the cluster components talk to NATs. So I run something like this, but actually Nats is on server 2. That way it doesn't have to, communicate across these two servers. The cluster talks all on the same server, and then the controller just talks to the node. And the reason why I do this is this server 2, this has all of my NVMEs, and they're not great NVMEs, and they will often fall off, and I need to restart this server to get everything working again. So if I have a third server or a fourth server, if I had the node on server 2, I'd be turning off my node and that would break my other servers. So I typically like to have my node on a separate server. And this is server 1. I actually host a lot of things like my home assistant, anything that needs to stay on 24/7, I put in server 1. And then if I need to restart server 2, that's fine. It's not going to break anything else. Now, if Nats is on server 2, this is why I put Nats over here, because if there's other um, servers that are on this cluster, it would break if NATS goes down because it can't communicate. So if you want, you can put NATS on this server 1 if you want to make sure that everything stays up. In fact, you should put the controller and the cache on server 1 and just have the plotter and the farmer on all the other servers, because you'll need the controller and the cache to stay up if you want plotters and farmers on other computers to still be working. So I don't go into this too in depth. I'm going to do an ultimate autonomies or autonomous video where I cover more in depth from like basically zero to finish everything to do with running autonomous clusters and getting your nodes and farmers going. But for the purpose of this video, I wanted to keep it kind of simple. So the main point here is with clusters, it's really configurable. So in this last example, let's say you have a bunch of servers that you want to just use to plot all your disks on server 1. You could have, a bunch of servers connected to NATs on server 1 that is helping plot all of your disks on a single server. And you could have a farmer running on each of these if these all have disks too, and then they all help plot each other. There's a lot of ways you can configure this. So just keep that in mind. And it's really just the only hard part with doing stuff like this is just making sure you're using the right IP addresses. So like when server 2 is communicating with NATs on server 1, you have to use the IP address for server 1. But like if you have all of these on a single server, you can actually use the internal Docker IP addresses to talk to each other within the same server. But again, if when you're talking outside of, from server to server, you need to use the server IP addresses. Within the server, you can use the Docker IP addresses. So I don't really cover that too much, but it's something to keep in mind. So setting things up, it's pretty simple. There's the official docs here, which they're pretty thin when it comes to clusters. There's some good information in here, but it's not really like a step-by-step walkthrough, but it's still good to look at. And then, so really just to get things started, I create on each of my servers that I'm going to be running. And in my case, like I said, I have two servers. I create a network on Docker called Autonomys network. And it looks something like this. When you run it, you get an ID back. Your ID will be different. It's kind of like a unique ID for the network. That just lets you know it's been created. Now, inside Portainer, you can use that network. So in this stack file, you can see that I am using Autonomy's network. That's the one I just created, and it's an external network because it's not specified inside this stack file or Docker Compose file. And it's pretty simple if you've ever run a node before. For running your node, the container name, I just call it Autonomy's node. The image, we're now using Autonomys. I keep saying Autonomys, but it's Autonomys. Uh, and then as of today, it's July 29th version. These come out pretty frequently, so if it's like a week or two or more, just make sure you're using the latest version. We are mounting our volume here, so there's a node data volume that's specified down here. And then we are opening our ports, make sure these are forwarded. So um, you can see there's an example here where I've forwarded these two ports. Make sure that you're using your own IP address here if you have to specify that. But you need to have these ports forwarded for the node or else you're not going to get a good connection and you might not stay in sync. This is going to restart it unless stopped. So if you restart your computer, the node will just start up automatically. This is all pretty standard. You can update the name to whatever you want. I'm specifying the Autonomys network and I'm assigning it a static IP address. And it's a good idea to just assign these a static IP address because if you were to run all of these on the same, like the node, the farmer, all the cluster components, you want to be able to point to each specific internal IP address. And this is what I'm talking about when I say internal, where we're assigning an IP address internal to Docker that's running on the Autonomys network, which has its own IP range here. Now, if when we in our next stack file, we're going to have to point to the node, and you're going to see I won't use this IP address because I'm calling it from another server. I'm going to use the server 1 IP address. And that's pretty much it for the node. And you can do hostname-i if you want to get your IP address. Let me just jump over to like Termius. So for Bender here, and that's, yes, Futurama, you can do hostname-i, and you can see I actually get the Docker IP addresses, but this 192.168.69.65, this is my server IP address internally. So you're going to need to know what that is for the next step when you connect your cluster to the node. So just jumping into Portainer here, Bender is where I'm going to be putting all of my Autonomy's node stuff. So just my node is going to be running on this, and we can see it's still syncing. Actually, it's like it's synced actually. So we're almost up to 40 peers. This only took me maybe less than an hour to get synced. So it's really quick. Snap sync runs by default now, so it'll get updated pretty quickly. And this is basically exactly what you saw in the dock here. The only difference is this is for Spaceport. It's a monitoring app that I've been working on for months. I'm way behind on it, but it's a friendly name that you can add. So you can keep this if you plan on checking out Spaceport. I highly recommend it. Nothing is out yet, but it's going to be pretty cool. It'll be able to track all of your stuff. It basically scrapes your logs and looks for like key events and then stores that in a database. And there's a web front end. I'll do more on that in the future. But running a node, which for me is step one, and you can run a node and a cluster and everything on the same server if you want, like I showed before. But for me, I'm just running my node separately so that it doesn't get restarted when I restart my other computer. Okay, next we need to for me, I'm moving to server 2. But if you're running everything on the same server, you're going to need to create these folders on that server. And we're creating 3 folders here, nats folder, a cache folder, and a controller folder. Nats is going to hold the config. Cache, this is like where cache is, I guess, like the blockchain for plotting. But you typically need about 100 gigabytes. I think I specified 200 just as overkill, but whatever the size of the blockchain is currently, it needs to be like a little bit bigger than that, is my understanding. And then controller, this is going to hold some of the controller files. So this doesn't take up a lot of space. You don't need to be worried about it. And then for the cache folder and the controller folder, you need to set the ownership to nobody and no group. And that's just so Docker can read and write to those folders. And the final outcome should be something like this, where you have the cache controller nats folder. These two are nobody, no group, and then the nats is just dev, which would be your username. For me, that's my username. And then now we need to update the nats config file. So what we're going to do is nano, which is like a text editor, and then we're going to open nats.config, which doesn't exist yet, but we can still open it. That's like creating a new file in nano. And we're going to paste in just this. So if I go over to Termius and we're in Bender, we can see if I do cat, which just prints out whatever file I specify. Um, ah, what's going on here? Oh, because I ran this in Bravo actually. Um, there we go. And then we do nats and then nats config. So we can see I have basically this inside that file. So you're going to need to create that, and you can do that just with this nano command and then pasting in the max payload here. Then you'll press Control X and then Y to save your changes and exit nano. And then if you're for every server that you're running the cluster on, you just need to create this Autonomys network or Autonomous network. So I created that already on my server. And if we move over to Bravo, which is where I have my disks, I can see under Networks tab that it already exists. So I've created it. You'll need to create it again. And again, you'll do that for every server that you're running some part of your autonomous network, your cluster, whether it's the node or a farmer or plotter, you just will create this. And these are all separate networks internal to each specific server. We're just creating the same network for consistency, so it's easy to copy and paste commands and stuff between the two. So back in Portainer, now we're on server 2. For me, that's called Bravo. We're going to create a stack called Autonomous Cluster. So in Bravo, if I go to my stacks, we can see Autonomous Cluster. And we have a bunch of components here. We have a nats service, we have a farmer controller, farmer cache, just the regular farmer, and then a farmer plotter. And if we go into back to our guide here, you can see it's all of these things. We have the controller, cache, plotter, farmer, and then nats. So back down here, this is the stack file that I just showed you. And this should have everything that you need in here. we're pointing to our nats config for nats. For the controller, we're pointing to where our controller is, our controller folder that we created earlier. And here's where it gets a little different. So nats, we're assigning it an IP address of 172.250.101. For the controller, you have to specify nats. So we're just using the same IP address as listed up here with port 422 because that's the one that we have exposing, which you don't technically need to expose it in this case because it's internal, but let's say you have another server that needs to talk to NATs, then you're going to need to make sure this port is exposed. But you can see I'm actually using my server's IP address for the node. So when I did that hostname -I, this is the server. And if you saw when we created the node, so we go back to Bender and we go into stack files, Autonomys node, you can see the IP address internally is 172.250.101, but we're going to be using the server's IP address. And this is what I was talking about. Anytime you're connecting between servers, you need to use the IP address of the server and then the port of whatever you've exposed through like this ports command here to connect to it. So because the node isn't on this server, I'm using that server that has the node, that IP address. But because NATS is running locally inside this Docker network, I can use the IP address that I assign it. And you're going to see on each of these, I'm using my NATS IP address locally that I've created. And uh, only your controller is talking to the node. So that's why you don't see it on any of these other ones because everything else just talks to NATS. Okay, there's a few things you need to make sure that you're updating here. So for the labels, again, this is for just for spaceport. You can update those, delete them, however you want to do it. You want to make sure you update your time zone so that it's correct. You want to make sure for your node, you're using your IP address. And again, you just go to the server that the node is on and you can type in hostname -I and you can get the IP address. And if you actually are running this all on one server, you could even be running your node inside this stack file and you could just specify it with the internal IP address. So just make sure you're updating that. And then you're going to want to make sure you put in your reward address. So you need a reward address to specify, and then you're going to need to make sure for each of the drives that you have. So I mount all my drives on media/autonomous/00. So that'd be my first drive, 01 for my second drive, and so on. So I only have one drive shown here. And I'm bind mounting it internally inside this container to /00. So when I'm specifying the path down here in the command, I'm just putting /00 because that's what I mounted it to inside my container. And then the size of this disk is 4 terabytes, but I put 3.7. So if you go into, if I go into Bravo and I do df-h, we can see that 00 is 3.7, and that's why I'm using 3.7. There's actually a little bit of extra space, like it's only filling up like 93%. So you could actually, because of how clusters work, you don't need to store the cache on the disk. You can use almost 100% of the disk, and I'm going to eventually fine tune this so it'll be exactly 100% of the disk is being utilized. So just make sure you add, and you can add as many of these as you want. It just depends on all of your disks. So you would just, duplicate this, do another volume with media/autonomous slash, wherever you have your disk mounted. And then down here you add another path wherever your disk is mounted. And that is it for that. In the end, you should have something like this where you have a cache, controller, farmer, nats, and plotter. All these would be running on whatever server. And that's really it. So if you have like 5 or 6 different computers, you can just replicate the farmer and the plotter part on each of those and then make sure it connects to the NATS, a single NATS instance. So you don't want to create multiple NATS instances unless you know what you're doing. There's a way to cluster the NATS so that if one server NATS goes down, you can use the NATS on another server. But unless you are specifically setting it up for that, which isn't covered in this guide, you're going to want to just have a single Nats instance and all of your farmers and plotters, or even just they can be just plotters too. Like if you have a single server that has a farmer with all the disks, and you have like a gaming computer or something that you want to just boot into Linux and run as a plotter to help plot, you can do that as well. So you just got to be careful with um, making sure it's set up correctly, because if you put the farmer and the plotter on a separate computer, when you're pointing to NATs, you have to use the server IP address for NATs, not the local internal one. So I know that's a little bit complicated if you're not familiar with this type of stuff, but I think the IPs are really just the most confusing part. So if you have any questions, feel free to leave a comment and I'll see if I can help you out. But that's an updated guide, and I mainly wanted to do this because Autonomous, everything's kind of changed. Like it used to say subspace here, so now it's Autonomous. So my old guides wouldn't have worked if you were to like copy paste something. So I will be doing, like I said, a larger guide. It's going to be like 7 or 8 videos. That's going to be like from zero all the way to, running maybe a more complex setup. But I'm trying to plan that out to launch with like mainnet. So I probably won't have this any sort of guide like that because we're still waiting on GPU plotters. There's like some changes that may occur, so I don't want to spend a bunch of time creating a really huge like ultimate guide if things are just going to be changing constantly. So that guide will be coming out, but hopefully this gets you started for now. All right, I'll see you in the next one.